Hello everyone. In this video, we will discuss on how to use SEL-3350 real-time automation controller. So this controller is having an software interface called SEL Accelerator Attack, by which we can create algorithms on the SEL hardware module. So in this video we will discuss on how we can configure this hardware module. So for the demo purpose I'll be using IEEE 9-bus system. The single line diagram of the test system is shown in this figure. So we will be getting ePMU data from the DSA2 software. So I have already discussed how to create ePMU or how to emulate PMU and get the data PMU data using DSA tools software in one of the previous videos, and in that particular video I have used 9-bus system. So the same data will be used in this SEL hardware module also. So let's see how we can create a new project. For that, in the accelerator software, you can see new project option. Click here, and you can see different attack types in the menu, and that you can select SEL-3350. Actually I am having SEL-3350 attack with me, so that's why I'm selecting this particular model. So you have to select your hardware accordingly, and the firmware version I have is R150, and the project time I'm selecting as default one. And after that, project name you can change it as your wish. Once it is done, you can click on create. And a new project will be opened as you can see in the screen. So we have different options like devices, track processor, tags, system will have main controller, like controller specifications, and few more like system tags and all. Then access points, user logic, virtual tag list will be there. So I have already created a project. I'll open that one. Okay, so as I discussed, we will have the ePMU data coming from the DSA2 software in one particular system, and the data will be we will have the data in the SEL hardware, and we can do some calculations using those data, and we will be sending the data to some monitoring software. That is the particular work which we are intending to. So we have to get the data from the DSA2 software to the SEL hardware module. So for that we can add like C37.118 protocol. So you can get it from insert, and from insert option you can click on others, and from there you can get this option. So here you can change the device name, and in the connection type you can see 4 options like client Ethernet, client serial, server Ethernet, and server serial. So we have connected these devices using Ethernet, and if you are selecting client Ethernet, then your SEL RTAC hardware will be acting as a client, and data will be the RTAC will be getting some data from some other device. And in case you are selecting it as a server, then the SEL RTAC will be sending data to some other device. So first we will see how we can get data from some other device to our SEL hardware module. So in this way you can click on insert. So a new device will be added. uh, So if you want to have this device added to the device option, then click here and again click on select the C37.118 protocol and continue the process like insert. In this way you can add a new PMU or a new SC37118 protocol to the hardware setup. And once it is added, there are, you can see four options here: settings, PMU, pin settings and controller. So this is the diagram for the controller, and in the settings you can select the transport scheme, that will be TCP scheme, and server IP address. So this server IP address is the address of the device from which you are sending the PMU data. So I am having the DSA tools installed in this particular system itself. So we can check the IP address of this particular system. So this address should be entered there, and server IP port should be the port number which we have entered in the PMU data, like TCP port, and you have PDC ID also. So say the same should be selected in the soft interface also, like here. So server IP port should be 4714 and PDC ID should be 2. So I have already created a device called simulated PMU here, and it is having 3 PMUs. So this PMU can be added in by clicking on PMU and click on add option. Select the number of PMUs which you want to have. In this case it is 3. Click on add, and you can see the station name and PMU ID. You have to change the name and ID according to the DSA tools name and specifications you have already given. So if you see here, I have given the name as Gen 1, Gen 2, Gen 3 and ID is 1. So the same should be entered in the RTAC also. I have already done all these works, and this is the PMUs which we have. So the device server IP address, I will change it to 10.128.4.127. Now we, after the programs, whatever we are intending to do with the SEL, we have to send the data to some monitoring device. For that we need another PMU, and that PMU should be connected to the monitoring software. So for that we need again output protocol. So again we will be using C37.118. In this particular case we will be using the protocol as the so server Ethernet should be selected, so that the SEL attack will send the data to some remote device. And here again the we have different parameters to be selected, like client IP port, server IP port, then the PDC ID, data rate, all those things. So the data rate is the data rate that we have selected already, like 60 frame per second was a rate that we have selected for the ePMU. So the same should be continued. And so in this case we have a PMU which we have created inside the SEL RTAC hardware. That can be done by selecting the virtual tag list, then select add tag list, and in this case you can use C37.118 server PMU, and you can give some PMU name and click on insert. So in this way you can create one new PMU, and you have to set the time reference, quality reference, and the tag names, and if you are sending some analog data, that should be specified, the phrases should be specified, all those things to be done. So I'm deleting this one. So all these things are already done. So the frequency reference is done as the frequency reference, frequency of the first PMU number 1. Likewise we can do, and there is an analog data called COIF, center of inertia frequency, that we will be sending from this SEL hardware to a monitoring device. Now so this tag should be entered in the tag processor, like you can see here the server PMU magnitude, instantaneous magnitude, these are defined as like COIF is the source expression, and the data type is also defined. Now in the system, like you have to do some you have to do some configurations. For example, like data rate, nominal frequency of the system is 60 hertz. Data rate should be the same as that of the sending end data rate, that is 60 frames per second in this particular demo. So we have to select 60 itself, because the PMU is having a reporting rate of 60. Then okay, now we have user logic. So in case we want to do some calculations, or we have to do some we have to find do some algorithm, or we have to calculate few new quantities from the input of the PMUs. In that case we can use user logics. This user logic can be inserted from this IEC 61131 programming language. So all the code will used inside the SEL RTAG will be coded using IEC 61131 programming language. You can see different options here, like program, function block, function, GVL. GVL means the global variable, data type, etc. So I have used global variable and program here, and in this global variable, so we will be calculating center of inertia frequency, and this frequency, that variable is defined as a global variable. And in the program, so this particular quantity is calculated, and it is assigned to the particular PMU as an analog value. Now so in case if you want to have a function block which we want to repeatedly use in the program, those things can be done using like by using function block, and also different options are available. um, with this almost I think I have covered the SEL. Now once this is done, once the programming is done, we have to go online. Okay, so I have created this, I am deleting this extra device which I have. So yeah, now I'll enter the password. So I have username and password, like So I have successfully entered this program to my hardware module. Now I'll open my DSA tool software and run PMU simulation. So I click on run, and we will go to the RTAC software interface, and if I select the controller, you can see the offline option should be false. If it is true, that means we couldn't get the connection between the hardware and the DSA2 software. As it is false, we it means that we are getting some, it's online and we are getting some data from the machine, from the hard software. So once the simulation is done, the controller will start getting data. Let's see by stopping the simulation. So we can see the message received count is getting updated, and the program calculation, the program will be updated and there will be calculation going on. The data is getting updated and the output will also be updated once the program is, once enough program is done. Thank you for watching.